Hi, today we will see FCFS scheduling algorithm, third example. Already we have seen two examples, right? So there we have the process and a burst time without arrival time, right? We considered all the process like P1, we just considered arrival time is 0, P2 for arrival time is 1, P3 for arrival time is 2, right? Last the previous example, but here we have the arrival time for all the process. Also here we have the burst time. So here we have to calculate the average waiting time. For calculating average waiting time, I will show you how to calculate the completion time, what is the turnaround time, and what is the waiting time, and how we can calculate it, and also how we can calculate for the response time. Okay, so now let's draw the Gantt chart. Okay, so this is the Gantt chart. So here we have the process, right? So we have to, there are how many process available here? There are 5 process, right? P1, P2, P3, P4, P5. Okay, so here based on the arrival time, the process will go into the queue. Okay, that will be executed first. So the minimum arrival time, first we can sort this process based on the arrival time, then we can put all the process in the Gantt chart, then easily we can calculate the turnaround time and the waiting time. Okay, so the minimum time for all the process, what is the minimum time? 0. Arrival time 0, so 0 assigned to process 4, so this will be executed first. Then what is the next minimum time? That is 1, so that is assigned to process 3, so uh, this will be executed next time, right? The second place. So what is the next minimum time? That is arrival time is 2, so this is the third. This process, a pivot process, will be executed third position. So what is the next minimal arrival time? So that is a 4, this is the fourth position to execute the process. What is the next minimum time? So 5, that is the fifth position, right? So let me add the position here. What is the first position? P4. Okay, what is the second position? P3. What is the third position? P1. What is the fourth position? P5. What is the last position? Fifth position? P2, right? Okay, so I told you whenever we write this Gantt chart, right, for all the process the starting time is 0, right, and the arrival time, here we have the arrival time, right? So the arrival time is 0, so that is the waiting time 0. So P4 how much time takes to burst this process? Where is the P4? This is the P4, it's assigned to 3. Okay, what is the next process? P3. So B3 how much time it takes? 8. Already P4 completed from the queue. Okay, so the ready queue. So the P4 process already assigned 3. Now sorry, P4 process already assigned 3. Now P3 process is going to execute, right? So the P3 process is burst time is 8. Already 3 completed for P4. 8 plus 3, right? 8 plus 3, 11. Okay, the next process is P1. What is the burst time for P1? 6. 6 plus 11, 17. Okay, okay. What is the next process? P5. So the P5, what is the burst time for P5? P5 burst time is 4. Already P1 completed 17. 17 plus 4, 21. Okay, for P2, right? P2, what is the burst time? 3. So 21 plus 3, 24. Okay, now we'll calculate the completion time and turnaround time and waiting time and response time. Okay, okay, we'll calculate all the time from this Gantt chart. Okay, so let me just complete this table, then you can easily understand how we are calculating the waiting time, turnaround time, response time, and completion time, finally the average waiting time. Okay. Okay, so the completion time means this is for each process what time it takes to complete. From the Gantt chart we have to take the completion time. Okay, so for P1 process, come to the P1 process. Here is the P1 process, right? What is the completion time? 17. The P1 process is completed 17. Okay. Next you can take the P2. So where is the P2? So here is the P2 process. What is the completion time? 24. Next you can take a P3. So P3, what is the completion time? 11. So next you can take P4 process. What is the completion time? P4, 3. Next P5, right? P5, what is the completion time? 21. Okay, 21, right? Fine. So now we have to calculate the turnaround time. Okay, turnaround time means completion time minus arrival time. That is the turnaround time. So completion time here, arrival time here, 17 minus 2, 15. Then 24 minus 5, 19. Then 11 minus 1, 10. Then 3 minus 0, 3. Then 21 minus 4, 17. Okay, the waiting time. Now waiting time is turnaround time minus burst time. This is the turnaround time, this is the burst time. So 15 minus 6, 9. 19 minus 3, 16. 10 minus 8, 2. 3 minus 3, 0. 17 minus 4, how much? 13. Okay, now we'll calculate the response time. Response time is nothing but here whatever we have the start time, right? For the process, start time minus arrival time. Okay, response time is start time minus arrival time. So here the start time for P1 process, P1, this is the start time for P1 here from the Gantt chart, right? 11. 11 minus 2, 9. Then what is the next process? P2. P2 where is? Here is the P2. So the P2, what is the start time for P2? 21. So 21 minus 5. How much? 16. So here next P3 process, what is the start time? 3, right? 3 minus 1, 2. Then P4 process, where is the P4? Here 0, right? Start time. So 0 minus 0, 0. Then the last process P5, what is the P5 starting process? 17. So starting time 17. 17 minus 4, 13. So here you can see waiting time and the response time both are same, right, for all the process. So when it happens, when FCS the given I mean the problem, right, it belongs to non-preemptive, then waiting time and response time always same. If FCFS is non-preemptive, okay, if non-preemptive, then waiting time equal to response time always. Waiting time is equal to response time. Okay, now we'll calculate the average waiting time. So average waiting time, we have to add this times and we have to calculate the average. So 9 plus 16 plus 2 plus 0 plus 13 divided by 5 process, number of process, right? So 19, here 9 plus 16, right? So here 25, right? 27, 30, 40, right? 40 divided by 5, so it takes 8. So average waiting time is 8. It follows non-preemptive algorithm, so the waiting time and the response time always same. Yeah, thanks for watching this video.